Hello, Algebra Scholars. This is section 4.2 on polynomials. Much like the previous section, 4.1, which had a lot of properties in it, section 4.2 has a lot of definitions in it. It's going to be important for you to go back and make sure that you look carefully at the handout, not the handbook, the handout that I gave out in class, as well as your textbook for all of the definitions. I'm going to go over some of them here, but this is not going to be a comprehensive lesson. You really need to go back to the handout you were given in class as well as your textbook. The first thing that I want to emphasize is the definition of the word term. Okay? So terms are separated by addition, not by subtraction. So, for example, if I ask you to list the terms of the polynomial 8x cubed plus 11x squared minus 4x minus 3, you would say, okay, well, the first term is 8x cubed, the second term is 11x squared, the third term is negative 4x, and the last term is negative 3. Because the reason for that is they are separated by addition, so this is really plus negative 4x cubed. Okay? That way you get the correct sign of each term. In this next example, I'm going to give you a polynomial shown here at the top of the screen. And the first thing I'm going to have you do is to write in all of the terms that we just talked about here. Remember, terms are separated by addition. So the first term is 4x cubed. The next term, be careful, is negative 2x squared. The third term is just x, and the fourth term is negative 1. Now I want you to list the coefficient of each of these terms. Remember, the coefficient is just the numerical part of the term. So the coefficient of 4x cubed is 4, of negative 2x squared is negative 2. Be careful here, the coefficient of x is 1. And there's no 1 written, but you could pretend that there's a 1 here for 1x. And the coefficient of a constant term is just the constant term itself, negative 1. Remember, the degree of a term, the next thing we're doing here, is simply the number of variables in that term. So there are 3 x's in 4x cubed, so that's a third degree term. There are 2 x's in negative 2x squared, so that's second degree. There's a single x here, and there are no x's in negative 1, so that's a term of 0 degree. And then finally, the whole polynomial has a degree to it. And remember, we're not adding up anything here, we're just picking the term that has the largest degree cubed, and that serves as the degree for the entire polynomial. So this polynomial here is a third degree polynomial. The next thing I want to do is talk about the leading term, the leading coefficient, and then we'll also review degree of the polynomial. The leading term, as you know from the handout and from the book, is simply defined to be the term of highest degree. So as we look at all of these polynomials, we're simply looking for the term that has the largest exponent. So we can look here, here. Let's write them down as we go. So leading term for this first polynomial is 2x cubed. For the next one, it's negative 5x to the fourth. Now for the next one, be careful. Leading term doesn't mean it has to come first. The leading term is the term that has the highest degree. It actually comes last here. So the leading term is negative 4x to the fourth. For this next one, it's just 5x. And for the last one, it's right here in the middle. It is negative x to the fourth. Now, if you've identified the leading term, identifying the leading coefficient is easy. It's just going to be the numerical part of what you just wrote down. So the leading coefficient here is 2. Here it's negative 5, negative 4, positive 5, and then negative 1. And then the degree of the polynomial is simply the term of highest degree, but that's the leading term. So all we need to do the degree of the polynomial is just pick off that exponent right there. So this is a third degree polynomial. This one's fourth. This one's also fourth. This one is a first degree polynomial. And this one is back to being a fourth degree polynomial. And the last thing I want to talk about in section 4.2 is combining like terms. And as a reminder, like terms are terms with the same variable raised to the same exponent. If they don't have the same variable or they don't have the same exponent, they cannot be combined. And by combining, we are talking about addition and subtraction. What I find helpful and what students have found helpful in the past is to underline like terms. So look for terms that have the same variable raised to the same exponent. So these are like terms because they're both x's, they're both to the fourth. And I'll underline these with 2 slashes because these are both x's and they're to the first power. And so these can be combined together. So we have 3x to the fourth plus 4x to the fourth gives us 7x to the fourth. So we're just adding like quantities together. It would be like if you had 3 motorcycles plus 4 motorcycles, you'd have 7 motorcycles. Nothing happens to the exponent when you combine like terms. And then finally we have negative 2x plus 3x, and negative 2 plus 3 is 1, so we just end up with plus x. We'll do the same down here. We've got some x to the sixths, we've got some x to the fourths, and then we just have some regular old x's here in the middle. We'll go in descending order. So 12x to the sixth plus 10x to the sixth. We now have 22x to the sixth. And then negative 2x to the fourth minus 6x to the fourth gives us negative 8x to the fourth. And then x, take away 2x, just leaves us with negative x. And that is all on combining like terms.